All right, so the Pythagorean identity is something that I'm sure you've seen somewhere, but it might just sound new. Yeah, but you've seen it somewhere, I believe. Okay, so Pythagorean identity is simply just sine squared x plus cos squared x is equal to 1. So this is the Pythagorean identity. So from this equation that I've written on the board, we can derive several equations that we can be using in solving identities and other trigonometric questions. So let me start first by dividing the whole equation by sine. So if I divide the whole equation by sine, I'm going to have sine squared x divided by sine squared x, then plus cos squared x.
Sir, you are fast.
I'm very fast. Okay, so I was saying this is the Pythagorean identity. This is the Pythagorean identity. And then I'm going to divide the whole equation by sine squared x. So if I divide sine squared and sine squared there, cos squared x, I'm also dividing it by sine squared x. Even 1 here, I'll also divide it by sine squared x. So when I do the division, the first one here will give me 1. The first one will give me 1, then I'll say plus. The second one here is going to give me, this is cos squared x over sine squared x. So remember what I said, tan theta is equal to sine theta over cos theta. And then the reciprocal of this, remember what I said? I said this is just cot theta. So the reciprocal of sine theta over cos theta, simply just cot theta. So this is the reciprocal. And since it has a squared, it means that we're going to put a squared on cot. So we're going to say cot squared theta. Then this is equal to 1 over sine. We said this is just the same as cosec squared x. So cosec can either be written as cosec x or cosec x. These two are just the same. So 1 over sine is cosec because it has a squared there, so we also add a squared there. So this is one of the equations that you get after dividing or after simplifying the Pythagorean identity. So let us now try to divide the same Pythagorean identity by cos. This time around, we're going to divide it by cos. So I have sine squared x divided by cos squared x. Then I have plus sine, cos squared x. I'll divide this by cos squared x as well. Then I'll have 1 over cos squared x. I've just divided this same equation here by cos. So sine squared x divided by cos squared x, the answer is simply just tan. Remember what I said? Tan theta is equal to sine over cos. So sine over cos, we're getting tan squared x. Then you also have cos squared x divided by cos squared x, the answer is 1. Then this will be equal to 1 over cos squared x. This is just the same as sec squared x. So this is the other important identity which you have to know. All right, so these identities are very important in solving, they are very important in solving identities in short. So let me look for one identity that we are going to solve together. Then you see how they work. I want to show you how these identities work. Okay, let me just quickly look for one question I want us to solve it together. So they are very important equations. You need to know them. Okay. Okay, I found one. So this one reads, prove the following identity. Let me just erase everything here. Okay. So the question is, prove the identity. Then let me copy the identity. We have sine x minus cos x squared. So we have sine x minus cos x, and then everything squared. So we've been told to prove that this is equal to 1 minus 2 sine x cos x, 1 minus 2 sine x cos x. So I'll get the left-hand side. So say, this is how you prove identity. So say let the left-hand side be equal to sine x minus cos x. So I have to prove that what I've been given here is equal to that. So let me begin to prove. Let me draw a line there. Okay, so the left-hand side is now equal to, so sine x minus cos x, when I square this is just going to be sine times sine. Or in other words, I'm trying to say this sine x will multiply with everything there, which is sine x minus cos x. And then negative cos x will also multiply with everything, which is sine x minus cos x. Why am I doing this? Because I know that this part here is just the same as sine x minus cos x multiplied by sine x minus cos x. Okay, so here we can now do the multiplication. So sine x times sine x, the answer is sine squared x. Sine x times negative cos x, this would be negative sine x cos x. Negative cos x times sine x, this is negative sine x cos x. So negative cos x times negative cos x, this would be positive cos squared x. So from here, what you can do is you can pair what you know You can pair what you know to say their identities. So from this equation, I can see this one and this one. If I put them together, they will give me a 1 from the Pythagorean identity. So what that means is that I'm going to get sine squared x. I'll pair it with this. So this one, I'll pair this and that. So sine squared x, I'll pair it with cos squared x. And then the rest of the part, I'll add it because this one and this one can add. So I'm going to add the remaining part, which is just going to be negative 2 sine x cos x. So this part here, if you remember the Pythagorean identity, I said sine squared x plus cos squared x. This one is just equal to 1. So while there is this expression there, I can replace with 1. So I'm going to replace this part with 1. So I'm going to put 1 there, and then I'll write the remaining part this side, minus 2 sine x cos x. So I have proven that the left-hand side is equal to the right-hand side. And then you can say, therefore, the left-hand side is equal to the right-hand side. Then you say, hence proved. So this is just an example. We'll do identities in the next lesson. I was just giving you an introduction of what we're going to discuss in the next slide.
I think it's just in the...
Huh? So this is just an introduction.
We are lost.
Okay, it's an introduction of what we're going to do. Oh, not really in the next slide, but in the next lesson that we're going to have. That's why I said I'm going to record the Pythagorean identity alone. Just from this Pythagorean identity, you can solve a lot of trigonometric equations. Yeah, so I'm going to prepare as many questions as possible on the proving of the identity. And then apart from that, hello? We also solve equations, not only about the identities, but also just normal equations, trig equations. Yeah, so in the next lesson, that's why we're going to discuss these. So the next lesson will only be based on 2 subtopics on trig. Trig equations and trigonometric identities, that's so. So once we just do those 2, we'll just remain with sketching. After sketching, we'll go to calculus. So this week, in other words, this week we're finishing trig. Next week we'll start calculus, which is the last topic.
The last one.
Yes. All right, thank you very much for attending tonight's lesson. See you in the next lesson that we're going to have.